Good afternoon and welcome to Metra Home Theater Tech Tips. I'm Brent.
I'm Adam.
And we're ready to get started because we got a lot to cover today, Adam.
We do have a lot to cover today.
So, what is today's topic?
Well, today's topic is actually kind of interesting, and we're going to start today's topic off with a quote. First and foremost.
Are we going to be literate today?
We're going to be literate today. So before I get into the quote, everybody, thank you again for checking in with us. And as always, if you have any questions or comments about what we're talking about today, please leave it over in the chat. We will get to that throughout the episode. If you are watching this after the fact and you want to leave your comments down in the comment section, please do so. We do monitor those as well. So as always, like, share, subscribe, hit that little bell notification. Share us out to all your different social media applications. So Facebook, Twitter, Reddit, Instagram.
Tell your friends, your neighbors, your parents, your children.
Exactly. So,
by the way, for everybody that subscribed, thank you very much.
Last week we hit our 1,000 subscribers last week. So again, thank you very much for that, everybody.
Now we're going to the big two.
Yeah, we're making it. So let's start off our episode with a quote for today. Ready? Once upon a midday dreary, while I pondered, weak and weary, I received a call that gave me woe. A customer called Poe. Poe.
On that happy note, I'm going to have to assume that today's episode is about Poe.
Yes, it is. So Poe is a major part of our lives as an integrator. We use it almost every single day, especially if you're doing surveillance systems. You're using it almost every single day out in the field where you're actually powering those cameras on an IP network system. So it turns out you're actually using it in a lot more places than you would think. And we'll get to that later on as well, because that's one of the things that we'll be talking about with that. So, without further ado, we're going to go ahead and talk about what it is we're talking about today.
Okay, let's talk.
We're going to dive right in. So,
now,
of course,
just for what it's worth, he is much more intelligent on this particular topic than I am. So I get to ask the questions today.
I've only had like 2 straight days worth of research, and that's the only reason that I'm one step ahead of you today on this one. So,
well, that and let's face it, you're a third my age.
Well, that too. I'm able to retain it a little bit better, aren't I?
I'm sorry?
Yeah.
Okay.
Yeah, we're going to, yeah, exactly. So, as always, everybody, thank you again for checking in with us, and we'll go ahead and start talking about Poe, and we'll start learning about it. So, also later on in this episode, we'll go ahead and talk about some of the different tech calls that we had during the week, and we'll see if we have any kind of new tech news to talk about, and see if there's anything going on in the industry.
Darn it, there was something that you and I were discussing earlier today that I wanted to be on the show, and
hopefully by the end of the episode, we'll get there, right? Okay, so. So the first question that we have today is actually going to be, let's see if it here pops up on the screen. What are the different types of Poe, Brent?
Well, actually, let's back up. What is Poe?
So Poe stands for Power over Ethernet. Now, this is kind of an interesting concept because you have the ability now to have your power, your data, your video, your whatever going down all just one single cable from whatever source device you have out to your other device at the other end.
All over your Cat-X cable.
Correct, yep. And so now this is used a lot in, of course, network devices. We have wireless access points. We have IP cameras. We now also have different types of displays. Someone like a Control 4 with their touch panels, they're all Poe powered. They also can be powered locally, of course, which is kind of a nice feature. But with that, they're all powered over Poe. Now, one of the big questions that we get a lot is when people call in and they ask us, well, what kind of Poe is your cameras? And that's a really good question because honestly, you need to know that going forward in order to have the correct type of Poe device.
And at the beginning, my question would have been, but there's more than one?
There's more than one. It turns out there is more than one. So what is Poe? So Poe is, and we'll get into how it works, but Poe essentially is that power over Ethernet. There's 3 different types of Poe, and there's 4 different standards of Poe. And we'll get into that next. So with the different types, and this actually just comes down to...
We got 3 types before standards.
Well, as we know, going into the different standardized, entities that standardize things for us, it's not necessarily about standardizing anything. It's really about just making our lives more difficult and... Yeah.
Okay, just check.
So, yep. So
we didn't, of course, say that.
Yeah. Hey, Ed, thanks for checking in on the episode. It's great to see you as always.
Which Ed is this Ed?
This is Ed. I'm gonna butcher the last name. Shellens or Skellens, one of the two. Let me know if I pronounced it wrong. I know I did.
Yeah. Is it his first pronunciation or the second pronunciation that is the correct one?
Correct one. There you go. So the 3 types of PoE. Now, this is important because this
Oh,
is...
damn it, you just took one of my questions.
Okay.
One of my questions was going to be, what are the 3 types?
I'll let you do the 4 standards, okay? Okay, all right. We'll get there, I promise.
I need a purpose.
Yeah, I know. So, 3 types of PoE. We have Alternative A. I'm holding one finger
Is
for A.
that a music choice?
We're going to go with this. Alternative B. And there's also 4 PPOE.
So is this like New Age and Alternative?
Yeah, we'll go with,
New Wave and Alternative.
New Wave, there you go, yes.
Not New Age.
So, this is where you ask me, what is Alternative A, Brent?
Okay. Hey, Adam, what is Alternative A?
Okay, so Alternative
Did I ask that
A,
correctly?
You did.
Okay.
Now, actually, I threw a curveball in here because Alternative A is actually interesting because Alternative A is not what we are used to using when it comes to PoE power.
No, looking at the data that you have provided me here with which to ask these questions.
Yeah.
Why?
So,
That's kind of a why.
exactly. Now, PoE is a lot older than we're used than we would think that it is. It actually, but it's not as old as we thought. So, it's after.
You're really messing with my head
I know.
today.
So PoE actually really only started after the 2000s. They had different ideas about the concept before the 2000s, back in the 10-100 days of networking. But as we moved into after that, or towards the end of 10-100, as we started seeing more of the gigabit requirements, they needed to go ahead and again standardize, and we'll get to
I do
standardization.
remember 10100 PoE. I am old enough to.
So what you see here for Alternative A, the way that this works is interesting. It transports the power on the same conductors as the 10-100 data. So when we look at 10-100 data, we're using pins 1 and 2, because that's going to be either the green or the orange, depending on which one you subscribe to. It should be orange, pin 1 and pin 2, and then pins 1, 2, 3, 4, 5, and 6. Nope. Where am I at? Nope. Pins 1 and 2, 3, and we're jumping over from 4, 5, 6. 1, 2, 3, and 6. There we go.
Why is 3 and 6 split?
Because why is 3 and 6 split?
As I recall,
Yep.
it's to minimize inductance and interference between the channels.
Right. Now, of course, as you and I also know, the differences between 568A and 568B is...
Yeah, it's purely cosmetics. It was manufacturers wanting to cover their warranty butts.
Yeah, exactly. So...
If you don't do it our way, we ain't going to cover you.
Exactly.
Xerox and IBM. Have a nice day.
Yep, exactly. So, when you are looking at the way that it does this is kind of interesting. Now, last week we did an episode on H2BaseT, and one of the concepts that we talked about last week was the different types of data transmissions. So we have 2 different types. We have open close, so 0,
basic digital.
1, basic, very, very basic digital. Then we also have voltage difference,
Which is what's used in HDBaseT.
which is what's used in HDBaseT, but it's also what's used inside of networking. So it's not as simple as just opening and closing the
It's
connection.
not just ones and zeros?
Well, yeah, at the beginning and at the end, yes, but the transmission of that data is not. So the way that this works is kind of interesting, and I'm going to let you control the cameras. Would you give me a top-down shot, Brent? So what we have is actually kind of neat. So what happens is we've got our voltage lines here. Now, on standard systems, what you would see, and Brent, you draw this all the time, you've got an I pattern, right? So we've got a 1 and a 0 and a 0 and a 1.
Or 0 volts and 5 volts.
Right.
Give or
So-
take some minor. But
this is cool. So this is your normal open close. So this will be our closed connection. Down here would be our open connection. And up here would be our closed. And of course, this is just a reverse. This is our open, and then our closed, and then our open. Now, the really cool thing about all of this is that when we go instead to doing what's a voltage difference, is that this doesn't change. Technically, the view of what you see here doesn't change. It's how it does it. It's no longer just opening and closing that connection. It's changing the voltage that's going down that signal path. So what we do is we go, so down here, let's say we have, this is at 4 volts. Then what will happen is that if they need to get from a 0, so 4 volts is not 4 volts is 0. Or 0 or 1. So 4 volts is a 0. Up here instead, the difference, now I'm going to throw a number out there. I'm not sure if this is entirely true on this, but we're going to use 5 as the difference in voltages to show that there. But, so we're going to say a difference of 5 volts will make the difference between a 0 and a 1. So we are starting down here at 4 volts, so this is actually better to show a 0 and then a 1. So if we want to go from a 0 to a 1, and this is at 4 volts, all that I'm going to do is I'm actually just going to increase this voltage by 5 So now 5 plus 4, of course, it's simple math. We wind up with 9 volts up here at the 1.
Is that new math?
No, this is not common math or
Okay,
common,
'cause I can't do
whatever you want to
Common Core
call it.
math.
Common Core, that's what it is. So how this works is actually really interesting because now this number here, this 4 volts, can be any voltage that I want to use. So what they do in order to get power across that connection is all that they will do is increase this voltage down here, which of course, whenever we increase the voltage, we can lower the amperage, which means we can go ahead and get signal across it, right?
Lower current is always better.
Right, so
because current's the tough one.
we can increase this voltage to whatever we want it to be. So in this case, we can, let's see, 12.95 watts when they bring it up to that. So we usually wind up with, I think it's about 12 volts for the original PoE. I'm probably wrong about that.
I think you're pretty close.
Okay, so we're going to assume I'm pretty close. So we're going to say instead of 4 volts, we're going to use 12. So when we go up from 12 volts and we want to do that swing of 5 volts, all I have to do is just add 5 to that to get a 1. So that means that this becomes 17 volts at the top. Now, the power that's being transferred across those lines is still is now able to transfer the data that's being transferred across those lines is still there, but now we are switching
More powerful
over.
carrier.
We can now have the power be sent down that same line because the voltages don't care.
Right.
It's the
all we look
difference
is
in
the
it.
differential.
Exactly. That's why it's called differential voltage.
And we can siphon off this voltage to run a device.
Right.
Because all we need is that 5 swing to know if it's a 1 or a 0.
Exactly. Now,
so it's just the baseline moving.
This is a really cool concept, and this is how they make it work. Now, this is also how HD-Base-T works on it. You can actually come back into it. I'm done drawing for this portion of it. So this is how HD-Base-T does it. This is how PoE does it. This is how a lot of different systems do it. In fact, I think this is also how HDMI does it.
Well, to some degree, and as we move into FRL.
Yes. Yes. So now, this is where things get kind of interesting. So what was cool about that is that was the first thing to come out. So instead of using the extra cable wiring that's inside of a category wire, they went ahead and retained those for a future use later on, and instead just put the power on the same two twisted pairs that they were using for the 10100 data. So then we go on into the next alternative.
Wait.
Here you go, Brent. You ready?
What is alternative B?
Alternative B is actually interesting, where in this case, this is more of what we would see in traditional PoE. This is what we see on our cameras here for Spyclops.
And this is what I think about as PoE.
Correct. So
The brown pair.
With alternative B, what it's happening is that it's actually separating out the power and the data. So you have, of course, 8 conductors inside of the HDMI cable, the category wire or cable.
This is the PoE show.
This is the yes. So yeah, exactly. So alternative B will actually separate it out. So pins 1, 2, 3, and 6 now are only data. Pins 4, 5, 7, and 8 are now power. Now the way that it does this is kind of interesting. I thought that it was only the blue pair that did the power. I thought it was just a single twisted pair. It's not. The blue pair is your positive. The brown pair is your negative.
And since we're not carrying any data, the differential distance doesn't matter.
It doesn't matter at all.
Now, is this an AC or a DC circuit?
This is a DC circuit.
And why is that?
Honestly,
Because
I don't
we have
know.
a positive
and we have a negative. There you go. Otherwise, we would just have
AC.
1 and 2 or whatever you want to call
L1, L2.
it. Yeah. So that's the difference between alternative A and alternative B.
And how alternative A was rarely employed in the early days?
It really was. It was one of the early ones that they released and wasn't used a whole lot from my research on it anyways. I know for our equipment here, for all of our cameras, we don't use that. So for all the Spyclops cameras, we are using pins, again, 4 and 5, 7 and 8 for our power.
Now, this was only for 10100 networks according to your research.
According to my research, yes, because as we move into from 10100 to a gigabit network, we are now in the ballpark of needing more than just 2 twisted pair to send the data. So that's where we come into play with alternative A more often than we do with alternative B. So you do get more of a gigabit connection when you use the alternative A, because now we're stepping over onto something else.
When we're looking at products, say the touchscreen for Control 4.
Yes.
I would ask about Crestron, but that's not your pigeon,
Nope.
so I'm not going to ask.
Right.
So is the Control 4 product an alternative B or an alternative A, or do you not know?
I don't know, but my assumption is that they're going to be using also an alternative B. Their touch panels
Are not high-speed data.
They're not high-speed data. There's not a lot going on there, except for the fact that they do have their intercom on there, which does video. But you
Yeah.
can do video on 10100 pretty easily.
Yeah, and the video reference, it looks like a 10100 video.
Right. So now, what's the next thing, Brent?
Okay. And by the way, I had never heard of this.
Yes.
So 4PPOE.
So 4PPOE. So it's not PPPOE with the old
No, it's
the old
4PP
DSL the old DSL
OE.
sign in. Nope, it's 4PPOE. Now what that means then is it just simply means 4-pair PoE.
So it's not an old man on a hypertensive drug frequently going to the bathroom.
Which you have full experience on that,
Yes,
correct?
I do.
Yes, you do.
4PP.
Yeah.
5PP, 6PP, 7PP. You can pretty much every hour on the clock.
I set my time to it.
Thank you.
Yeah. So.
Well, that's much like our announcement at every hour on the hour.
Yeah, exactly.
It tells me.
So 4PPOE, and that gets to be a mouthful every once in a while, it uses all 4 twisted pairs for its power. Now,
It's using alternative A.
Yes, but no, because alternative A doesn't use 2 of the twisted pairs.
My guess is it's using the format, which is the differential.
It uses the differential.
But on all pairs, so we can carry much more voltage down the pipe. And more data.
As we get into, so of course, gigabit network is now pretty much a standard thing to put into everywhere. Yeah, exactly, to get all that information. Man, it feels like there's something actually grabbing me. But what will happen is now we are getting into
Paranoia?
2.5. Well, yeah, paranoia, yes, there it is.
That's that thing I flipped under your collar that...
There you go. So what will happen is as we get into 2.5 gigabit networks, and then also 5 gigabit networks, and then 10 gigabit networks. So of course 10 gigabit networks are the new thing that everyone is looking for when they're building new houses.
Particularly for IP over AV over IP.
Exactly, because we're going to need that bandwidth for AV equipment. And before I go too far, everybody, again, if you have any questions about anything I'm saying, this is a lot of information all at once, but I'm hoping that this will be good information for you going forward to know what to look for and what to ask for when it comes to your PoE equipment. So definitely, if you have any questions, definitely throw it down in the comment section below. Also, let us know. We're looking at let us know what you're using for one, but also let us know. We're looking at a concept of bringing it in. Did we lose our? Oh, yeah, looks like I lost that. So you are it over there. So what will happen, what we're looking for is we're potentially looking at bringing out a system where we can go have your questions brought in, and the best question could potentially win a little bit of cash.
Ooh, the Brent bucks.
The Brent bucks.
The Brent bucks.
So pardon me, it's not cash. It is credit for here.
In my opinion, it's better than cash.
So let us know if you think that's a good idea, and definitely put that down in there.
Yes, if you haven't had Brent bucks yet, they're the most amazing and awesome things in the world. And I'm very, very modest about the Brent bucks.
Yes, you're very modest about it. Let's see. I need to move this over here because I need to be able to see the questions as they come in. But
yes, because I cannot.
So the 4P PoE. And how it works is, like you said, it uses the differential voltages on the system so that it's able to tell when there is it's able to still get the data across
at high speed
at high
large
speeds
quantities.
Because we're using 4 twisted pair as we get into the higher bandwidth requirements, but we can still continue to have power sent over it. Now, what's really interesting about 4P PoE is that you can actually now send across a much higher amount of power. And that's where things get really interesting as we move forward. This is actually looking at an interesting thing for the commercial environments. As we were talking about last week where we had the HD-based-T episode, we have many different manufacturers that are putting POC-powered displays out there to where you can send an HD-based-T and power down a single strand to that television. They're also releasing 4P PoE displays that will then allow you to put them out there as well.
Now, is this something that's real, or are they actually shipping these products?
That I don't know. So it's one thing to look at different ideas for being able to spec different jobs that are out there. If you're needing to have something out there that will do that, look into that as an option. That may be something that's out there that some different manufacturers are doing. Look at the different TV manufacturers. NEC especially has some great commercial and televisions. Samsung, Sony, LG, all the big guys out there that are doing that. Now, we have the different standards. Those are Those were,
this
of course,
is,
the three types of PoE.
Yes, now we have the standards.
Now we have the standards. So the interesting thing about the standards, let's see if I, nope, oh, there we go. Now it's back on. I think I'm good on this side. So Harold is asking, what is the exchange rate for Brent bucks to US dollars? Honestly, it'll be a 1-to-1.
Towards purchases
here at Metra. So if you like the idea, let us know. And basically what it's going to come down to is whoever responds with the best question or the best comments.
We'll come up with a reasonable amount of Brent bucks. And I liked your idea on the spinny wheel.
About the spinny wheel. Spinny wheel was kind of cool. So we're looking at that too. So we'll see if maybe whoever wins the previous episode will do the spinny wheel, and whoever, that means we'll spin it, wheel of morality, turn, all that kind of good stuff. So let's get back to PoE and talk about what are the different standards. So, there we go. Very nice. That'll work. So the different standards, of course.
Yeah. Now this was something. We're all used to IEEE standards with numbers and alpha characters.
Yes.
And there's a lot more going on here, honestly, than I knew about.
Yes, there's quite a bit.
So, and it's interesting to see how they break it down.
Yes.
The different groups. So, I guess you're going to start with IEEE 802.3 AF.
Yes, AF.
Yeah, we're going to not make any jokes.
Because it really is.
AF.
It really is AF.
AF.
No, so 802.3 AF is actually just the standard for regular PoE. Now, regular PoE, it requires 2 twisted pair. It actually is the alternative B. So that means that we have 2 twisted pair for data and 2 twisted pair for power. Yes. Now,
which is why DC cameras work on it.
The reason that they have so many different standards is because you can apply the different types of PoE at different power levels. Yes. And I'm going to say power levels because it's not just voltages and it's not just amperages, it's actually just wattage. They calculate the wattage.
Right. And the system's intelligent to determine which one to employ.
Yes, it is, which we'll actually get into how it does
that. And that's actually when you explained that to me.
Yeah.
That was pretty cool.
Yeah, that's kind of interesting.
Like, ooh, that's right up there with HDMI stuff.
Yeah, it is. Exactly. So, the way that it works is 802.3 AF, which is just standardized PoE, which is an alternative B,
which we've been using since day one.
Which we've been using for a while, and that's what all of our cameras are here, of course. They require...
And most everybody on the...
They require, they supply at the powered device, the actual camera.
The port or the DVR.
Yep, so
the switch.
Yep, no, other side. So
the other side, the receiving...
Yep, the receiving device.
Receiving the power.
Exactly. So, and actually, this is a good way to actually, to say this. So, the PSE is the power supplying equipment. The PD is the powered device. So, okay. We're talking about the PD right now. So the PD, on the standard of 802.3 AF, it requires at least 12.95 watts at the powered device. Now, the nice thing about this standard is that it allows manufacturers to say, okay, I can operate at 12.95 watts. So then at the other side, they take that power. They know that they're going to have that much power at that side. Now, that doesn't mean that, of course, we have 12.95 watts coming out of the PSE, the power supplying equipment. That can increase because of distance.
Right.
Right. So that can increase all the way up to 15.4 watts. So a lot of information with this, a lot of headroom. And actually, the headroom actually increases exponentially. If that's the correct term for that. Is it exponentially?
No, it's not exponentially, but it does increase as you go up.
Yes,
absolutely. And in fact, possibly in some cases substantially, but not exponentially.
Correct. Okay, that's probably the better way to look at it. So that's 802.3 AF. That's what all of our standard PoE cameras are using, not the PTZ cameras, but the PoE cameras.
And standard for what you generally do for access points, VoIP devices, things like that.
Yeah.
So as an industry standard, that has been around pretty much as long as it's been PoE.
Yeah.
And it's still a good chunk of the products till we get to power-hungry devices.
Right. So what we have after that, of course, is IEEE 802.3 AT. So this is, of course, like AT, like the Star Wars. Is Siri trying to talk to you?
Yeah, you heard whatever you said.
Well, whatever it was.
Siri.
Sounded like, yeah, there you go. So the 802.3 AT is not a Star Wars walker.
Not an AT-AT?
No, it's not an AT-AT. That is the standard for what's colloquially known as PoE Plus.
Do we get B.A. Baracus with the AT?
I don't get that reference.
A-Team?
Yeah, sure.
Children.
Again, if it came out before I was born, I'm not gonna be able to.
I get it.
Granted, I know the A-Team. So now PoE Plus is interesting because it still only requires 2 twisted pair, and it's only doing it the same way as the alternative B. It's using 2
bigger power supply.
Correct. It's just a bigger power supply. So now with 802.3 AT with PoE Plus, it now supplies up to 25.5 watts at the powered device. So now we can use a lot more power, right? For those larger devices at the other end.
More LEDs on the cameras, or possibly
PTZ,
motorized for PTZ.
Yep, yeah, or even for wireless access points, for the high-powered wireless access
greater
points.
Range.
Greater
like
range.
we did outside.
Exactly, yeah, over at the beach house. So, now, of course, that also has a maximum output of 30 watts at the PSC, the power supplying device, or power supplying equipment. So again, over distances, that's only about 4.5 watts of difference between when it leaves it and when it goes out to the other side. Now, it does adjust itself based on the resistance of that line.
Yeah, we'll get to that because that was.
But we'll get to that. Yeah,
that was cool.
Yeah, we'll fly through the next 2. So the next one is, of course, 802.3 BT. And it's not, that doesn't stand for Bluetooth, it's just BT. They just went ahead and honestly, I don't know exactly what that means. But
they're starting to run out of alpha characters.
Yeah, they actually have 2 802.3 BTs. They're Type 3 and Type 4. So again,
and there's a substantial difference between them.
The standardizing system is actually kind of interesting. I don't know why they don't just pick one.
Because it ain't standardized.
It's not. Yeah, it's that whole flathead, Phillips head, Roberts head, all that kind of stuff, right?
BT3 and BT4.
Yeah.
Nope. Or BTA and BTB.
Nope. So what you have, of course, is 802.3 BT, which is PoE++. These 2 different setups, the Type 3 and Type 4, are the newest. These are so new, they came out in 2018.
Well, now, you and I have already dealt with switches that are capable of supporting this.
Yes. So we're not using it yet, but this is where that 4P PoE comes from. So at that point, we are now requiring, the 4 pairs. We are now requiring, at Type 3, we're requiring at least 51 watts, so 51 watts worth of power at the powered device, 51. Because when they look at it, it's 5 and 1 on their side.
Okay.
Yeah, not 5 my side and 1, it's 5 and 1.
Okay.
Okay. As always, guys, if you have any questions, leave it down in the chat section over there, or if it's down in the comments below. So at this level, at 51 watts at the powered device, that's a lot of power. Because if you then convert that back over to, say, 12 volts, and then you do the math on that, you've got quite a bit of amperage to work with at the end of that line. And
it's the amperage that runs stuff.
Exactly. So that's at 51 watts, and then of course it's 60 watts at the output, and then Type 4 is 71.3 watts, a full 100 watts maximum output at the PSE.
Now, these are the switches that have the dual power supplies in them for supporting the...
Yes, these are the
a lot of juice in this.
Very large ones. Now, the really cool thing about this is that they actually call out use cases on this on PoE's website. They actually call out the use of it for charging laptops and powering flat screens.
Isn't that what HD Base T was supposed to do back at the beginning?
Yes.
With the 100 watts capability?
Exactly. So now, and actually, we're going to talk about the HD Base T stuff because it's really interesting, and we'll definitely talk about that. So that's how it is actually going to get that much power across it, because it's using 4 pair across the category wire, and it's still able to get with differential power, and it's still able to get that high amount of data transferred all the way across. So.
Okay, we're on page 2 now. I feel like Paul Harvey.
We're on
page 2.
Page 2. Let's see if I can get this thing to go through correctly. And there it is. How does PoE work? I think we just did how does PoE work. So we're actually gonna talk more about that actually. So.
Well, now, in our conversation, one of the things that happens before we do these shows is Adam and I will sit down so we have some kind of idea what the other one's going to say.
Yeah.
Not that it ever works that way.
No.
But that's the goal.
Yeah.
So Adam makes this wonderful little sheet because I'm an idiot. And he says, Brent, here's what we're going to talk about today.
Yeah.
And going over this stuff, this is legitimately exciting to me.
Yeah.
Because this very much resembles what we deal with day to day.
Yeah, with HDMI.
In the HDMI.
Exactly.
So how does it know what system to use, Adam?
So in order to know what type of system, what standard it is, because a lot of times when you have a PoE++ switch, it's capable of going backwards to just standard PoE.
One would assume that it is, yes.
Right. So what it does, and this is really interesting, so this is the startup procedure, this is the boot up process. The first thing that it does, of course, at boot up a point, or let's say you already got the switch up and running and you're hot plugging an IP camera. Technically, you're not supposed to. So it's best practice to first unplug power to the switch and then plug in your camera.
Hey, how often does that happen?
Yeah, never. So, unless, of course, there's something out there that says that you absolutely must do it on this model. No, it's not going to happen.
No.
So here's the deal.
You plug it in and you wait.
Here's the deal. You plug in actually, let's do this. You plug in a non-PoE device. Here's what happens. The system will send out a very small amount of voltage.
Not harmful.
Non-harmful. It's 2.7 volts down that line. And what happens is it's looking for resistance on the other end. Now,
specific resistance value.
Exactly. Now, normally, non-PoE devices are not using that connection in order to send back the allowed resistance back to the system. So what it does then, if it's not seeing that resistance at all, so an infinite resistance,
it doesn't turn on the power.
It doesn't turn on the power. So that's why you're able to take a non-PoE powered device and plug it in there, and it doesn't fry the circuitry inside of it because it's specifically looking in the initial setup process, initial boot up process for that port for that resistance. Now, that does not include Ubiquiti has some devices that are PoE. It's their own kind of standardized PoE that they have that is just on. It's always going to output power no matter what. It doesn't care.
Yeah, be careful plugging power supplies from one brand, standalone bricks from one brand, into other device. Don't.
Yes. So
switches are generally safe and are intelligent.
Yes.
Power supplies, bricks, maybe not so much.
Well, and even like Ubiquiti, they have their switches that are not, where they are just only outputting power and data, but they're meant to be used with Ubiquiti systems. They're not really meant to be used by themselves or with other brands and whatnot. So, did I reverse that? So Ubiquiti is really only being operated with their own equipment.
Yeah, it's a closed system.
Not with other systems.
Think Apple.
Yes. Yep. Exactly. So, the way that it works if you have a PoE device is that the system will then turn on, it will look for that specific amount of resistance, and if it gets that resistance, it will then do the next thing. It'll find out how much resistance, what type of resistance. It sends a couple other pulses of voltage down the line. So it will start at 2.7 volts, and then it will increase from there until it gets a specified amount. Now, I'm not sure exactly what that is. You might have to do a little bit of research on your own.
10.1 volts.
The max of 10.1 volts.
Right.
So
we don't know. It does not give us a crossover chart from impedance to voltage.
Now, I will say that this specification here is for PoE and PoE+. This is not the new PoE++, the 4P PoE. So this is a little different. So for the new stuff...
because the new stuff, and I would assume because it's using all 4 pairs, there's an entirely different interrogation process.
Yes.
It's probably much more complex.
Correct.
Because it's not just voltage, and now has to determine how to parse out the data.
Exactly. So if the power device presents a load of 0.25 to 4 milliamps, that starts up PoE. But if it presents back instead, oh, that was the same amount. I think they either got a wrong number there or something else. But they didn't. They gave me the wrong number there because it's the same as before. I might be wrong about that. But what will happen is that if you have the Class 2 or the PoE Plus, you will see a 14.5 to 20.5 voltage from the PD first. And that's just to verify that, are you really PoE or are you PoE Plus? Kind of, yeah, exactly. Now, then at that point, then it does a startup voltage, which is greater than 42 volts, and that's to actually get the system powered on. It's that inrush of power, so they can go ahead and get started. And then from there, for normal operations, it stabilizes anywhere from 37 to 57 volts. Now, if it's that's for PoE. If it's PoE Plus, it's anywhere from 42.5 to 57 volts. So the voltages can range. And in most cases, they do, depending from one manufacturer to another.
And distance and impedance and because there's a lot happens. It's not a cold, ignorant connection.
Right. It's just whatever the manufacturer is looking to use inside of that range of connections. And that's why PoE has now become a standard that other manufacturers can use. So we're going to jump ahead. because we're running out of time, and I do want to talk about some other things, but there's also the matter of POC to talk about.
Power over cable.
Exactly. So, what about POC? So, here's the difference.
Power over cable goes way back in our world to the early days of satellite.
Yes. Now, here's what's interesting about this. The power over cable isn't so much about power over coax. This is actually still power over Ethernet. However, it's used by HDBaseT. So the biggest difference is that all it comes down to...
other alternatives to HDBaseT, the less expensive ones, also will use a POC format.
So they use kind of. They use, so like for instance, our entry-level extenders that we have, they use POC, whereas HDBaseT, pardon me, I was actually incorrect. Those extenders do use POC. Now that's power over Ethernet cable. That's just cable. Power over Ethernet, power for HDBaseT uses what they call power POH, and that's power over HDBaseT. The only difference is between PoE and POH is the data. The power is handled the same way as PoE Plus. So it's still using 2 twisted pair for the power and 2 twisted pair for the data. So,
and then it has to pan 10 the other data on top of that.
Yes. Now, kind of. It uses HDBaseT is still actually using all 4 twisted pairs for its data. So it's actually using, all the way back at the beginning of today's episode, it's using alternative A for its power. So it's taking 2 twisted pair and using it for power, but they're also overlaying or multiplexing or duplexing.
Multiplexing with PAM10.
PAM10. They're multiplexing that over top of the power. So that's where that...
Which is more differentials.
Which is more differentials. So,
and different frequencies.
Exactly. So that's where we come into play, where we have the differential... the voltages may start at 47 volts, and then from there, the differences between 47 volts and I think PAN10, I think uses a total... it's 10 steps or 16 steps for PAN16, but the actual voltage difference is only 5 volts. And so what they'll do is they'll take anywhere from 47 volts, and they'll go up from 47 volts to 52 volts. And then at 52 volts, they have 47 to 52 volts to use for the data transmission. And that's where they break it down into the different steps. That's where they break down those 5 volts down to 16 different layers for that.
To spreads.
Yeah, exactly. So that is how HDBaseT is going to power their displays at the other end of the line.
In theory.
Yes, in theory, which is actually technically... and they're talking about being able to do that now. The possibility of doing a full 4P PoE, so 4P PoH, on their systems. But we'll see. I'm not going to speculate too much on that and how they're going to do it, because that's kind of an interesting setup.
One of the manufacturers, and I think it was Sony, way back at the very beginning at the announcement of HDBaseT, because they were part of that alliance, actually showed a panel functioning on the category cable.
Yes, and actually you can see those. I mean, they're out there. They're the power over HDBaseT stuff. It's mostly in the Infocom world, the commercial world, but they're definitely out there. I do know HDBaseT is really pushing for it to become more of a standard inside the home.
Which is why you want to go to Cat 6A.
Yes.
For nothing else, extra copper matters.
Yes, it does.
Loss is definitely different between Cat 6A and Cat 5e.
So that's actually an important thing to talk about, because when you have a good cable going in between the transmit device and the receiving device, and in this case it'll be a PoE switch of some kind and a powered device, PD, you want to make sure you have good quality copper in there. So it's Cat 6A, which is a thicker gauge copper. It's got better windings inside of it.
Better twist ratios.
And with that, what you're going to wind up with is the fact that it's less loss, but it means that your device that's giving power doesn't have to work so hard. Because if we now have to send out, let's say we use the 4P PoE, where we have a max output of 100 watts at the port, that means that device is working all out if it's having to push that much power across it.
To max across the port.
Exactly. And so that's going to add a lot of wear and tear to your system. You want to go ahead and decrease that. And it will die
earlier.
It will. You want to decrease that as much as possible, and it starts with the infrastructure. Make sure you've got good cables in there.
It's infrastructure week.
It's infrastructure week, man. That's really what it comes down to. Good infrastructure, and we're finding out why it's good infrastructure that does this. We're finding out that, look, if you're going to put that, okay infrastructure in there, or sub-okay infrastructure.
Pushing it.
Right, and that's why, yes, PoE works over Cat 5e. Yes, it works on Cat 6, which is the standard that you should be using for HD-based-T, but it's better to use the better cable because you're going to increase the lifespan of your transfer device.
And the reality is, whether it's networking, cameras, or HD-based-T, you really should be laying in Cat 6A now.
Yes.
Cat 5e should be nothing more than tying your trunk closed.
Yes. So I learned something kind of interesting during my research of all of this, because one of the big questions is fiber, which actually we're going to be doing a fiber episode, not next week, but I think the week after that. It might be next week.
I think it's next week, because then I'm gone. No, it's the week I'm gone.
No. You're still here for this one, if I remember correctly. Anyways, but I digress.
Okay. I'm here for 2 more shows after this one.
Yes. So the interesting thing while I was doing all this research is fiber, power over fiber. So POF. It's been done. It's interesting.
How efficient is it?
It's not. It's really not.
You're actually having to blast the hell out of a photocell at the other end.
Yeah.
To generate juice.
Yes.
Because that's what you're doing. Your solar energy.
Yeah, exactly. You're basically putting a solar panel at the other end to receive that power.
And they're not efficient.
They were not, and it was not really anything. I mean,
other than
you lose the
efficiency.
Do this. Yeah, we can do it. I don't see it happening anytime soon where we're actually going to get that, because of course you have the standard solar cell degradation, which is like 20%. So until they get that number much higher to where we're not losing nearly any power across that, then we'll maybe see something like that. But right now, definitely not. But it was kind of interesting that they are using it, and not using it, pardon me, but it's in a lab.
Experimented.
They're experimenting with it. So it's definitely kind of an interesting thing. If you guys have more questions while we're here, definitely ask those questions for us in the chat section. Or if you're checking us out after the fact and you want to leave your comments down in the comment section below, please do so. As always, subscribers, thank you so much for getting us past the 1,000 subscribers. It's interesting. We're growing very quickly, and we really appreciate that. A like, a share, a thumbs up, or that is the like. A like, share, and hitting the bell notification.
Send money.
Send money, buy our stuff, and with that, we really appreciate it. But as always, if you have questions and stuff, leave it down in the comment section. We do monitor that even after the fact. You can also contact us here at our tech support line, 386-492-8584. You should also see it down in this section here below. And then, of course, you can email us at adamr@metrohometheater.com or brentm@metrohometheater.com.
And most of you know my cell phone, my number, which is 866-839-9187, extension 2203. That is the office line, but it follows me to my cell phone wherever I am.
So, Harold, this is true. You are actually correct.
Harold called you out, did he?
No, he didn't. He's actually got a good question. So, Harold is asking, and again, is it Ullery or Ullery? Let me know in the comments. I always want to pronounce the names correctly, or just call me. Yeah, we'll talk on the phone. So he's saying, could you not, in theory, create a device that uses a fiber and a cat cable between the balins or the extenders?
You could,
and use the cat just for power.
Absolutely, you could.
Definitely.
In fact, I would take it further than that. I would use the cat for eARC.
Yep.
And you know what? We're just gonna, yes, and we'll keep going because,
keep going.
We're gonna keep going.
Keep going.
Yeah, never mind.
So. Yes, and where Brent's taking this is also kind of interesting. So technically, you could take a device like that and you'd be able to transmit only the data connection or only the video information. Let's use an HDMI extender as an example. So you could technically just send just the video information down the fiber, gain that increase in bandwidth because of that, and you could use the category wire instead to handle things like EDID. It could handle things like Brent's saying, like eARC and ARC, CEC. Power, of course, which then at that point it's very easy to do because all the other stuff is super, super low bandwidth.
And this is not a new concept. It comes down to, do you guys want to pull
2 wires?
Multiple wires.
Now, of course.
And can we sell you a product that requires multiple connections?
Let us know. Actually, in fact, let us know. Is there demand for both a category and a fiber to be Siamese together in a single reel? If you want that, let us know in the chat and in the comments, because if that's something you guys are looking for.
Cat 6A, because we want to carry as much current.
Yep.
Not just voltage, but current, because remember, that's how you make the wattage, is voltage and current to get to the wattage.
You know, the interesting thing about that idea is that you're actually increasing the durability of the fiber, because now the Cat 6A becomes the backbone. It's going to protect it. So not a bad idea. If you guys have that, if you guys are looking for something like that, let us know. And maybe we can bring out something like that for you guys so we can supply that for you.
The other nice thing is, just for what it's worth, you could the category cable and the fibers don't have to be anywhere near the same length.
No, in fact, because of course the transmission of light.
It's just a separate,
exactly.
entirely separate trail.
Yep. So you don't need that clock out of it because all that's being handled by the fiber at that point. So you don't even have to worry about that. So in theory, yes, very much so. But it also means, like Brent was saying, pulling 2 wires. It means pulling out a fiber.
Terminating 2 wires.
Terminating 2 wires. Pulling out the fiber termination kit, terminating that on both ends, and terminating it with a Cat6A, which is not as easy to terminate as standard Cat6 or Cat5. Unless
you're using our Cat6A terminations.
Which is actually kind of cool.
Even
you use
an old man.
That little punch down. In fact, I think it is your hands doing that in the video, isn't it?
Even an old man can do that. You did the audio, I think, for it, and I did the...
it was either me or Stuart, one of the two. If you go back after this episode and check our YouTube channel, we actually have an episode on our Cat6A terminal, and you'll notice the hands in there. Those are Brent's hands doing it. And Brent, your hands are not as strong as they used to be.
No, arthritis is a...
Yeah, but it works.
It works.
It worked really well. So.
And the terminal, in my opinion, is actually an easier terminal to get correct than a standard category terminal.
Yeah.
Because when you put them in those positions, you're done.
Yep.
I mean, it really is an awesome, and it's not an inexpensive terminal.
No. But it's a good thing.
But it's a great terminal.
Yeah.
I would use that terminal even on a standard 10 gig system. You still need to use Cat6A.
Yes.
But it's a great terminal.
And
I would highly encourage you to
use
try
those on your HD-base-T and your PoE networks.
It will work better.
It'll make a huge difference for those types of connections. So
termination.
Brent, do we have any tech calls that we should talk about?
Maybe that was it. There was some thing, and
I can't think of it either.
And here's what happens, guys. We get back here, we cover things, and then something else comes up, and so we got to talk about that, and then it's just gone.
Yeah. So with that, guys, as always, give us a call if you have any tech support questions. We are here Monday through Friday. In fact, we're here on Saturdays too, technically. However, Saturday is set aside for Spyclops tech support.
Which doesn't mean don't call us, because we'll answer the call.
Yeah, we'll still answer the call.
And those of you that know me know I'm available from 8 a.m. to 10 p.m. 7 days a week.
So none other than what we learned last week with the and the week before that with the industry. Are we still now? Last week you alluded to one thing that we weren't allowed to talk about live on air. Are we able to talk about it yet?
That yet?
Not yet.
We did talk about the fact that 2.1 still at 40 gigs, right?
I don't think we did. Let's verify.
Okay.
Let's talk about this. So the new Xbox Series X, the new PlayStation 5,
all the new 8K televisions, are not 48 gig.
No,
they are
40
8K.
gigs. Yeah.
But they're not 48 because the only chipset that's available is only a 40 gig chipset today.
Correct.
So be careful your promise. You can still give them 8K. You can still give them 4K 120, which for the gamers is a much better. 8K 30 is going to be very jittery because the higher the resolution, the more obvious the frame rate becomes.
Yeah, and with 48 gigs, you can do a lot, even with HD. You can get all the way up into, we're seeing 360 refresh rate
and
on some of those monitors.
And let's be honest, if you're anything under 75 inches, 4K is plenty of resolution.
Well, granted, we were saying that when 4K was out, so it was coming out about
1080p is plenty of resolution. Nobody needs more than 6 gigs of RAM, 6 meg of RAM.
Yeah. Now, if you're one of our eagle-eyed viewers, you may have seen that our TV is down on the wall. It's actually new, as Brent says. And so, just to give you an idea, that's an 8K TV. You can't tell the difference. Granted, you're watching on a phone, on YouTube or something else where you're not going to see the difference on it. However, it's a brilliant TV. We're very happy to have it. It is a Samsung.
With one Connect box.
With a one Connect box.
Which does have a few things that annoy me.
Same.
For example, the USB ports are on the side of the One Connect chassis.
We won't get into those details. We're going to talk about the fact that we're very happy with it right now, especially since we've got an 8K TV in the lab. So, but with that being said, we're very happy with it, and we'll talk more about that.
We do have an additional AVR coming in the next week or so, I hope, and we'll go over that when it arrives.
Yep, that'll be a good piece. Maybe we could do an unboxing. That'd be kind of neat. Could we do an unboxing?
I have no idea if it arrives in a box.
Let's find out. Let's find out. That'd be kind of neat. We'll do an unboxing and a review.
We should have done.
Yeah. Would you guys like us to do an unboxing and a review of? It's a Sony, correct? Coming in for the AVR.
And just fair warning: when you unbox this, be damn careful. You were not there at CES when we unboxed it. But, you know, typical, you put it down, you release the bottom, you lift the top up. And we weren't watching what we were doing. The one connect box, which is very heavy in this television, is in the very top of the box.
Yes.
Which makes the top of the box very tilty and top heavy. And it whacked the out of me at CES, which Stuart found quite entertaining.
Oh, I'm sure. If I was there, I would also have found it quite entertaining as well.
You guys were laughed.
Yeah, of course. So, all right, guys, I think that's it for today's episode. As always, a like, a share, and a subscribe is very, very helpful for us. We want to get the news out there for all the stuff that we have going on. And then, as always, questions, comments, stories, interesting tidbits, whatever you've got, let us know down in the comment section below.
If you've got a better idea on what we're doing, please tell us.
Yeah, definitely. And again, we're not always right. If we miss something, let us know. Call us out on it.
We try to be, but...
Yeah, exactly. So,
and by the way, particularly if you're calling him out.
Oh, yeah, definitely.
Absolutely.
Yep, definitely. So, with that, everybody, thank you again for checking in with us. We'll see you all next time. As always, Brent, reboot early, reboot often.
Don't cut your wires too short.
Turn off CEC.
And call tech support.
I'm Brent.
I'm Adam.
Thanks. We'll see y'all next time.